Good day and welcome to the first Future Flight Friday event for 2021. I am Carissa Khan, the Innovation Lead for the Future Flight Challenge, and today I will be discussing the economic benefits of Future Flight. Next slide, please. So the Future Flight Challenge recently published a socio-economic study with PwC. Today we will share a brief summary of the findings, followed by a panel discussion with experts specializing in drones and advanced air mobility. We'll take questions at the end as much as time will allow, but if there are any questions that are unanswered, we'll take these offline and provide you with a Q&A document after via the KTN. Next slide, please. Thanks. So we're all enthusiastic about the third aviation revolution, and the Future Flight Challenge is tasked with developing the aviation system in the UK that will enable this. But we need to ensure that this future aviation system is not only fit for purpose, but also addresses actual needs. So we set out to understand what are the societal benefits of these new classes of air vehicles and future flight services. How can it benefit society? How can it make our lives better? And how can we ensure equitable access? We recognize that we needed to start by understanding the socio-economic levers and drivers, and this will also enable us, the socio-economic levers and drivers that will enable the introduction and adoption of these new technologies and services. Next slide, please. So we commissioned a study with PwC to assess the potential costs and benefits of a selection of use cases and to identify the potential stakeholders that would be impacted by these new technologies, and also inform the future flight community of the incentives across the value chain. It provided us with a better understanding of the potential to be had from these new aviation technologies. And I hope that you, the future flight community, will find value in the results and be encouraged by its findings. Now I'll ask Craig Roberts, PwC Drones Lead, who led the study from the PwC side, to present a brief summary of our report. Craig?
Thanks, Carissa. So next slide, please. So how do we do this? Well, we used our total impact measurement and management framework, which gives us a more holistic view than we might find with a standard economic modeling approach. The first thing we did was to establish the use cases, and we worked with the FFC team to agree a range of use cases which we hoped would capture the wide range of areas they could invest their funds in. The next step is to go through the customer journey for each use case to understand the costs and drivers, and from that we can build a bottom-up economic model. With that in hand, we can take a bit of a step back and look at the wider implications of the use cases. You can see in this diagram on the right, we have a number of things we could consider. And obviously in the interest of time, I can't go into this in great depth. I'll pick a couple out. So let's pick greenhouse gas emissions and accident rates. So what we do is we understand those factors, so greenhouse gases and accident rates for the use cases. And then we allocate a financial value. So we turn them into pounds and pence, and we add that onto the economic model we had in hand from the first phase to arrive at total cost. So at this stage, we've got the total cost of these use cases, these future uses of aviation technology, and we need to compare that against something. So we compare it against the way the use cases are currently satisfied. So business as usual. We do the same thing we've done before for the use cases, and we arrive at a total cost. And the comparison of those two total costs, well, that gives you how attractive each use case actually is. Next step is to identify the winners and losers for each use case. Once that's done, we can do a bit of tire kicking, so we can apply the sensitivity analysis to each of the use cases. Now, in this particular project, we looked at a number of sensitivities, for example, passenger numbers, which has a major impact in the advanced air mobility use cases. We also looked at things like speed of the vehicle, the maintenance regime, the CapEx assumptions, and last but not least, we looked at the degree of autonomy. Next slide, please. So I've mentioned use cases, and again, we had a good go, we hope, with the FFC team at covering a wide range of use cases. So here we have 6, 3 are drone and 3 are advanced air mobility. In drones, we've got infrastructure inspection, so power line inspection, and we've got a couple of delivery scenarios. We've got a last mile one, which is a delivery of prescribed medicines, and we've got a cargo delivery scenario as well. And we're particularly excited about the potential for cargo delivery with drones, and actually that's one of the panel discussions that we have after this slot. The other panel discussion is advanced air mobility, and you can see that the middle clutch here are AAM scenarios. So we've got low capacity, short hop in the urban and rural air taxi scenarios. And then we've got slightly longer endurance and slightly higher capacity with a sub-regional air taxi scenario. So what I'm going to do now, again, pretty quickly because of the time we have, is I'm going to dive into each of the use cases one by one and just explain what we actually took into account and the result of each use case. Next slide, please. Okay, so the first one I'm going to look at is a drone classic. It's power line inspection, so infrastructure inspection. Now, these use cases are very detailed and very specific. So in this case, we're looking at 615 electricity pylons in the middle of Scotland. Now, they're spread over 220 kilometers, so quite a lot of range to cover. And we're assuming the drone base, we're in Scotland after all, is in Edinburgh. Now, in business as usual, what happens is the team will hop into their 4x4 in Edinburgh. They'll drive to central Scotland, over hill and under dale, and they will clamber around these not particularly nice environment. Well, sorry, I should say very attractive scenically, but not very nice from the point of view of actually capturing drone data. Sorry, I'm Scottish. I should be saying how wonderful it is in this particular part of the world. But it is practically difficult because you've got to walk between each of the pylons. And this means that you have quite a lot of time on the ground. It's a bit of a health and safety risk. It's not an ideal scenario. So in the use case, we're saying, okay, let us go into the near future and imagine a drone that is flying BVLOS from the Edinburgh base. It's flying to the location of the pylons, and then it's capturing the inspection images that are required for the standards and utilities. Now, something to bear in mind here is this is quite a special drone. So it's a VTOL drone that can't just VTOL in the sense of taking off and landing, but it can hover at its location. So it can hover at the asset to capture the inspection images that are required. And so what we found here, sorry, I should mention one other practical thing. So we didn't go for the ultimate use case here. We actually assumed that while you have your pilot at the base in Edinburgh flying this drone BVLOS, there's actually a field helper who's meeting the drone at certain predefined places selected for ease of access to swap out batteries and things like that. So this is quite a practical and gritty use case. We can imagine this happening in the quite near future. And the punchline here is it looks very attractive. 34% more cost effective at the total cost level, but delivering the same quality of inspection images as you would get from the VLOS inspection approach. Okay, next slide, please. Okay, now we're looking at last mile delivery. Now, a couple of caveats here. So last mile delivery in the sense of, let's say, a major online retailer delivering into the middle of central London into a flat, that's not very easy to imagine as a viable scenario. So we've taken a particular niche scenario here. We've taken prescription medicines and said, okay, can we model the use case for prescription medicines being delivered from a pharmacy or from a central hub to some homes? The other key assumption here is with the use case, the drones are able to actually drop off their valuable packages in a secure location. And so we're assuming that the deliveries are to homes and that there's some sort of drone kiosk or drone kennel, I've heard them described as, which could be in a skylight or it could be on the property. So again, it's a niche analysis, but it does give an interesting insight into what's possible. Business as usual in this case is actually an individual popping into a van from the pharmacy, driving to the homes and then driving back. And so here we find that obviously the drone will fly a more direct route to these locations, these homes, and we also find a saving of 21% overall. So again, bit of a health warning on this. I'm not saying with this particular slide, I should say we're not saying with this particular slide that last mile delivery is a slam dunk. It looks great in certain niche scenarios, but overall a bit more work to be done on that particular scenario. Next slide, please. Okay, we're getting into AAM now, and we have a sub-regional air taxi. Now here we're looking at a particular route in England where there's no direct train route. So quite a lot of changing of trains and waiting about required. The journey is about 108 kilometers. If there were sorry, I should say one other point here. Now, with all the AAMs, we do have this big CapEx assumption that we're at this sort of near-term scenario where there's not very much global production. Yeah, so around about 500 units globally per annum. Obviously, if we change that assumption and the technology starts to gain momentum, becomes ubiquitous, then the economies of scale will have a dramatic impact on the attractiveness of the use case. So bear that in mind. Anyway, back to this particular use case. So what we're saying here is we use a battery-powered air mobility vehicle with 12 seats, one pilot, 6 passengers, and the journey time overall, this is including waiting time, is 1 hour and 23 minutes. And the alternative is just the standard train journey, where the total elapsed time is 3 hours and 23 minutes. So quite a significant time saving there, but also with our modeling, we see quite a significant cost saving as well, total cost saving, that is, holistic cost saving. Now, this is a minus 47 delta. If we add 3 further passengers into the assumption, a bit of a sensitivity analysis there, we can see that the attractiveness, of course, improves. Next slide, please. Okay, getting into the shorter hop and shorter capacity AAM scenarios. And this is a 25-kilometer journey going from village to village or village to town. Same assumption in terms of the number of AAMs that are being produced, not a great deal. CapEx is a big deal here in terms of the impact on the pricing. And business as usual is a car. It's hopping in your car going from A to B 25 kilometers. So very easy to, I guess, find that in the average case and not particularly expensive. The use case then is a 4-seater AAM vehicle. One is the pilot. This is the piloted assumption here, so quite nearish term. And the other seat is taken up by 1 passenger. And we can see that there's an assumption here of about 10 minutes of waiting time. Now, this use case does not look attractive. The use case of the future use of aviation technology is 65% more expensive than hopping in a car and going from A to B. If we add, however, 1 passenger, so again, it's a 4-seater vehicle, 1 pilot, 1 passenger in the base assumption. But if we add 1 passenger, so 2 passengers in total, it becomes much closer to the business as usual scenario. So you can imagine that the sensitivities around the AAM use cases are really quite powerful. They have a big impact. And so, you know, it's not a slam dunk for these particular use cases, but they do look interesting when you start to play with the levers. Next step, please. Thank you. And just completing the set of advanced air mobility, we have an urban air taxi. This is a shorter journey. It's 10 kilometers within a city. And again, what we've imagined here is a business user who's hopping from meeting to meeting. And so perhaps there's a higher tolerance for cost. And the comparison is against a ride sharing or a ride hailing service. And of course, we have a number of factors in that model for business as usual, things like congestion and so on and so forth. And you know, with the use case here, it's very similar to the rural AAM use case. It is a 4-seater vehicle, 1 pilot, 1 passenger. And here again, you know, we do see quite an interesting impact. If we increase the number of passengers assumed from 1 to 2, we get to this actually being an attractive use case. So again, what we expect to happen with AAM generally is, you know, niche use cases will start the adoption. And in this case, it's a business use case where perhaps the amount of opportunity cost of time per hour is quite high. And so an additional high cost of AAM is attractive. But you know, as things move on, it becomes more ubiquitous. The production costs come down. The infrastructure becomes more widely spread and more accessible. We can see some momentum happening here. Okay, next slide, please. Okay, and we're finally on to cargo drones. So this is going to be the first panel discussion topic that I mentioned before. And what we're doing here is looking at a transportation every weekday of 2,000 kilograms of cargo, again, from Scotland, Inverness, to an island called Kirkwall. And the distance here one way is about 169 kilometers. Now, what we're looking at here is replacing existing air freight, actually using an ATR plane, with drone delivered air freight. So it's a straight drop-in replacement with the air freight, of course. It's a standard manned aircraft. It's going from airport to airport, so from Inverness to Kirkwall. With the drone, we're assuming we can build a relatively low-cost landing strip near the Inverness mail depot, and it's going from that landing strip to the Kirkwall airport. And so, again, in a similar way to the power line inspection, quite easy to imagine this in the very near future. There's nothing too, shall we say, heroic in terms of assumptions about this particular model. And you know what's fascinating here, and we're quite excited about the cargo drone use case, is that the costs look compelling even in that sort of cut down version. So before you are going directly from depot to depot, going from a depot to an airport, just dropping in and replacing air freight looks very attractive. And the particular drone we've modeled here doesn't just have a 350 kilogram carrying capacity, which is quite a lot in the scheme of cargo drone solutions at the present time. It's also got quite a large cubic meterage, so a volume capacity as well, which is quite important. So in this case, you can see we have a 35% difference between the use case and business as usual. So this is a very attractive case to perhaps consider a bit further. Okay, next slide, please. Okay, so in summary, and I think I'm just about on time here, the analysis, as you've seen, suggests that in the majority of use cases, the technology is quite exciting. There's a lot of potential for these future aviation technologies with 4 use cases between 20 and 48% lower than current. Now, I've mentioned a few times in this presentation that for the AAM scenarios, for the short hops and small capacity, passenger capacity scenarios, it doesn't look so great, but there are a number of assumptions in the model, and the sensitivity analysis tells us that this is, again, potentially an exciting area for future development. Bit of a caveat to finish, and please, I kind of refer you to the main report. We have assumed that things like societal acceptance, which are critical, of course, the regulatory scenario or regulatory environment is not a barrier. The supporting infrastructure and technology ecosystem, things like UTM, electronic computing, et cetera, are all just there in place. We've actually allowed ourselves a free hand and assumed those things were not a barrier. But of course, life is not that simple, and each of these things would have to be considered in turn. Okay, so finally, just summarizing the table here, you can see that we have quite a lot of attractive use cases: power line inspection, sub-regional air taxi, and cargo delivery looking particularly attractive. And we then have some other cases here where there's perhaps a bit more work required to just kick the tires, to use that phrase, on the sensitivities, and just make sure that we're hopefully driving the market to address the challenges we saw in these use case models. Okay, that's it for me. Can I pass it back to Carissa?
Thank you, Craig. So now I'll introduce our expert panel. First, we've got Charles Cale, CEO of Windraces. Windraces specializes in providing transportation of humanitarian aid using UAVs in hard-to-reach areas. Svilin Rongelov, CEO of Dronamics. Dronamics specializes in cargo drones for long-haul delivery of goods such as pharmaceuticals and food. Furquan, Technology Manager of Future Flight at GKN. And Daryl Swanson, Strategic Advisor for NASA and Subject Matter Expert for Advanced Air Mobility. Welcome. So I'll kick off with drones. The Future Flight study highlights an economic benefit of up to 35%, as we've seen, for the use case of cargo drone delivery. This looks very compelling. Does this reflect your views on the economic benefits of cargo drone delivery? I'll start with Charles. Sorry, Charles, I think you're on mute.
Quick unmute. Yeah, no, absolutely. I mean, I think there are a number of benefits. I think there are cost benefits to come through. Clearly, this is nascent technologies, nascent markets. But yeah, no, certainly. I think there are environmental benefits as well. I think we're talking about a lower carbon forward transport at the moment compared to traditional aviation, manned aviation. And I think the opportunity there is to be routing stuff more directly. So I think there's a quality side of this as well, that you go more direct to the final consumer.
Okay, thanks. Svilin?
Yeah. Hi. So definitely we see that cost savings are a major driver of decision making for cargo customers. This has been the case a long time before drones, and will continue a long time after. In our case, the unmanned aircraft and the surrounding system we're developing, that's why we didn't just take an autopilot and stick it on a Cessna. We decided that we need to start redesigning from the ground up in order to capture all the potential efficiencies in the process of design and manufacturing, so that we can then pass them on to the actual users to get that benefit. And like Charles said, this is the first stepping stone, right? As the technology evolves, the metrics will get even better.
And so Dronamics is developing the Black Swan that's capable of transporting 350 kilograms of payload over 2,500 kilometers. And that has the potential to reduce cost by 50%. What attracted you to this type of drone application?
Well, we were inspired by the Amazon drone announcement 7 years ago. My brother is an aerospace engineer, so we felt that the small drone delivery, we did sort of the same process that Craig and his team did for this. Obviously not in that level of detail because at the time there wasn't as much data and there weren't as many developers. But just on the basis of analysis, we decided to focus on, look, there will be great players in last mile, but we prefer to focus on the middle mile. We saw that there's a lot of underserved markets, a lot of, around the world, there's more than 50,000 airfields, 50. So in commercial aviation only touches, less than 5% of these. So there's a lot of communities that will be able to get the benefit of aviation if if there were vehicles that could serve those markets. So we decided to focus on a platform that is not meant to cross the Atlantic or Pacific. It's not meant for long continental journeys, but rather regional vehicle, a flying delivery van. So that was the rationale.
Okay, I see. And Charles, Windraces, the drones that you're developing can deliver up to 100 kilograms of humanitarian aid in these crisis countries over 1,000 kilometers. What attracted Windraces to this type of drone application?
Well, it was close on 5 years ago that Stephen Wright, my co-founder, and myself sat down and said we should really be doing something to, I guess it would be our third careers. So my background has always been in aviation logistics. An old colleague of mine went to work in South Sudan, and I've always kept a close watch on development in that country. And we fundamentally believe that these UAV technologies can actually produce a step change in medical and food aid delivery in countries like South Sudan, these World Food Programme emergency zones. There are 500,000 children who are fortunately suffering, and we do believe that this technology can lead to a step change. And in some stages, as in some situations, aid takes up to 6 months to get to the end recipient. And with what we've developed, the Ultra platform, we're looking at covering a country like South Sudan in 6 hours. So it's a complete step change, and it's a direct to village. Right? So that's what we're looking at. So you're bypassing multiple handling situations, difficult infrastructure, non-existent infrastructure, and basically getting to the parts that are impossible to reach. And then we've got a very capable platform as operating, and as you've seen, we've been linking islands up, and we'll talk about the regulation environment going forward. But there are 101 commercial possibilities now with this platform that we're coming through, and obviously those will be attractive to us because it will help us to perhaps subsidize our more aid delivery sort of aims with the organization.
And we can definitely see the social benefit of this type of use case. So how important is private investment for developing cargo drones? So Charles, Windraces is privately funded, it's a not-for-profit organization. How attractive are cargo drones to investors, and what has been your experience in sourcing private funding?
Well, we've, as you said, we've privately funded this, and that continues. We've obviously won some projects within Future Flight as well, which has been great, and we're pushing those along quite well to be operating to the Isles of Scilly again, and also up in Scotland. So that's great news. So we've been approached by a number of organizations that see us as being a very attractive proposition. I think we are. I mean, without a doubt, there's a big market out there globally. When you consider countries like Canada and Australia, island nations like Indonesia and things like that, the connectivity and linking to sort of remote communities is very, very difficult. And I think then you bring the angle in that actually there are many routes, even in the UK, that between 100 and 500 kilos is very attractive. And if you can move away from the manned aviation and reduce carbon emissions, this is very attractive to a lot of organizations.
And the sustainable agenda is very high on government's list of priorities. So Svilin, I'll ask the same question with respect to private funding. What has been your experience, and how important is private investment for your organization?
Well, I think private investment is the most important type of investment for any organization, because the economic incentive is perfectly aligned with that there's a product that the customers ultimately want. In our case, we're entirely privately funded. We have a number of investors from aviation, logistics, and technology, both individuals and also some funds specialize in that. And it's been very important because the geographical spread of them to be able to open the doors at the right places. So it's been very important. One thing I could say is that when we started, we decided to focus on, like Craig mentioned, a very big volumetric design of cargo hold, which was the result of our realization that that e-commerce is going to play an increasing role in trade in air cargo. So so that's why, you know, as of late, the most interesting conversations actually, especially as a result of COVID and the pandemic and the rise in e-commerce, have evolved precisely with people who are interested in e-commerce logistics and moving into that same day connectivity to cover a whole country.
Okay, and I think so. This is why we ran these numbers, because we hope that investors would be attracted to the use cases that would help organizations in our future flight community. So how would you describe the opportunity for cargo drones in the UK, and how does this compare with international opportunities? Svilin, I'll start with you.
Sure. Well, as Charles mentioned, different countries have different needs and also obviously geographical constraints. In the UK, it has the benefits of having perhaps the most dynamic e-commerce market in Europe, and one of the most dynamic ones in the world. At the same time, the businesses are not huge, but there's definitely challenges to provide same-day service on a national level. So we are examining a number of opportunities commercially outside of the Future Flight project that we're also part of for the NHS in Scotland. So I would say the UK, and credit goes to also the local CAA, is one of the most promising markets for cargo drone technology.
And we are witnessing an increasing trend of hyper convenience as well, where we want fast delivery very quickly with our generation. Charles, what about the opportunities in the UK for the cargo drones that you're developing?
I think, you know, fundamentally there is you know, quite a bit of opportunity. Obviously, you know, we are a very sizable economy, but we're not a very sizable country. So the opportunities in a larger country are going to be more numerous than perhaps the UK. But what is interesting is what we're seeing is this technology and our platform is really open the eyes to many organizations the possibilities of closing down issues that they have, which they can't really solve and haven't been able to solve them for decades, perhaps, or forever, on sort of quality of service. And there are, you know, the existing transport providers and infrastructure just isn't there and it's not convenient. And I think particularly as well with the health service, they're looking for more flexibility in supply, and this sort of platform does offer that flexibility.
Okay, and so Craig, you're drones lead for PwC. What are your thoughts about the opportunities in the UK?
Yeah, I think I touched on this before in the presentation, but for me, you know, delivery drones last mile look pretty challenging in most scenarios. There are niches, but they're pretty challenging. Whereas middle mile cargo drones, it's much easier to imagine those making an impact in the near term. So we expect cargo drones to very much be the vanguard for the last mile drones. And so that would be the first perspective. Just to pick up a few points from Charles and Svilin. The other thing about cargo drones, it's not just you know, more cost effective, better for the environment, but also we've spoken to a number of large logistics players. The quality improvement is quite exciting for them as well, because they can get more control over their logistics process, and they can essentially serve the same logistics amount of freight in smaller chunks, which gives them more control and higher quality. So there's quite a lot of excitement there. So for us, cargo drones in the UK, we can quite easily imagine that. We've done a lot of modeling, not just for the FFC, but for some of our clients. And it looks very attractive because, again, you can, what's interesting with Windraces and Dynamics is both drones are actually, they're fixed wing. Yeah, they require a runway. Whereas, I would say if I went back a few years, the conversations were, cargo drones have got to be VTOL. They've got to have, they've got to be able to land on a dime. And so the sort of practical approach that Charles and Sven have both taken really is a good indication of the potential value in the market. It's easy to imagine. The logistics companies can understand how cargo drones would drop into their existing logistics chain. And so we think it's really quite attractive for those reasons.
Okay, thanks. And so what are some of the barriers to implementing cargo drones in the UK? And what do you think should be the top priority of the sector to address these challenges? I'll start with Craig, go ahead.
Yeah, so I think the main barriers are going to be the regulation to get the delivery drones flying in the business as usual. And again, as I said many times, drones in POC are great, and that's fantastic. But unless you actually adopt the drones at scale and integrate them with your business as usual, you don't get the benefit to UK PLC you're looking for. And so to have business as usual for cargo drones, they need to be flying in unsegregated airspace. And so that whole regulatory UTM piece is going to be required. Something else I should touch on here. So both of the companies we have here, Windraces and Dynamics, have done what we call the sort of drone up approach to the solution. So they've started with a blank piece of paper and said, okay, we understand logistics. This is the drone we want to build. But other market entrants might be coming from aerospace down, if you like. And in that case, they may have a number of advantages, but a much higher cost model. And so somewhere in the middle there, with regulation and other technology ecosystem elements, if those are in place, you can deliver business as usual. And then that will generate a real benefit for the UK economy. So to summarize that, for us, it's flying in unsegregated space routinely is going to be what's key. And that will require, again, a number of things from the regulation standpoint, from the drone technology standpoint, and from the rest of the technology ecosystem. So that to me is the main barrier.
Okay, Charles, do you want to jump in?
Yeah, it's regulation. That's what it is. It's the ability to operate outside. What we have to do is, at the moment, we have to set up temporary danger areas. These are very, very clunky and very, very costly to set up, and only for short term. So if we're looking at doing things long term and routinely, the regulatory space needs to change. We're pushing along in that. We have some good ideas, which we're socializing, and we're aiming to solve that problem as well, particularly. And I think we just look forward to that change, but we need that really in months rather than years.
Yes, absolutely. Svilen, what are some of the barriers, and if you can have almost like the top of your wish list to address this, what would that be?
A few months ago, I would have also said regulation, but with the new drone rules that came into effect in the EU, and actually because they came into effect the very last day before Brexit, so on December 31st, they were sort of grandfathered in the UK. There will be some differences, and that's from here on out, the paths may diverge and probably will a little bit. But what's also important, but it's still a big breakthrough that now they exist, because when we started several years ago, there was nothing like that, and this also made it hard for investors or customers who say, yeah, we understand the business case, it makes sense, but what do I put in my spreadsheet, right? Like, which year do we start flying? And then now that this has changed, I think the laws of nature are the same everywhere, right? Weather is different, but if a system can perform a certain way in a certain country, then all that data should be relevant to all the other countries. So even if there's a difference in regulation, I anticipate in the next few years they will largely disappear, and yeah, there's a lot of work being done behind the scenes on an intergovernmental level to achieve that anyway. So it's definitely a challenge, but it's slowly going away as a challenge.
Okay. And the Future Flight Challenge is engaging heavily with the CAA to support our projects, provide that one-to-one service to help get those regulations. Like you said, Charles, we need it in months as opposed to years, and the Future Flight Challenge is a 4-year program. So we very much echo that sentiment. Okay, thank you. Thanks for your time. I'm conscious of time. I'm just going to move on to the advanced air mobility discussion now. So Craig, Perquin, and Daryl. So the largest economic benefits in the study was highlighted in the use case for sub-regional air taxi up to 48%. So, but the urban and rural use cases seem more challenging. I'll start with Daryl. Does this reflect your view of the market, and what are your thoughts on some of the assumptions that we've made?
Well, I definitely agree that the sub-regional aviation case makes sense. It absolutely does, because this is where aviation comes into its own in terms of giving people back time that they desperately need, where the transport connections on the ground, so other modes of transport are not as helpful. The rural case, again, I think what the study has proven is a bit of common sense. Is why would you travel by air 25 kilometers when the roads aren't that congested? But it is a use case to look at, and it's really about the definition of the use cases, and that's where the work that I'm doing with GKN and the Skybus project is actually opening my eyes to some of the definitions. The urban question, of course, I always originally scoffed at some of those shorter models, 10 kilometers. Why would you do that in a city where you have great public transport? But not all cities have great public transport. So it really comes down to the regions and the areas that you're looking at and specific use cases, which make it challenging. So I completely understand the use cases that were set out in the PwC report. Whether or not you'd be looking at that for London, who knows? But certainly something that we've been looking at on the Skybus project is where those use cases in a city setting actually start to make sense. And I'll let Furkan talk about that and some of the work that we're doing.
Okay, thanks. Furkan, do you want to share your thoughts on your view, and does the study reflect your view of the market?
Yeah, I think it's extremely difficult to accurately forecast economic benefits like this for a disruptive concept like advanced air mobility. And many people will have different views, different numbers. There are also several indirect benefits by providing a faster method of transport between two places, especially when you're doing things like reducing congestion on the ground. Sorry, it's just a motion sensor. Yeah, when you're reducing congestion on the ground, you're not only directly benefiting the people using that faster aerial transport service, but also the people who are using traditional ground transport. My opinion is that regardless of kind of the operating environment or the generalization of the use case, if you can find a route that is currently extremely congested, it's inconvenient or really poorly connected, then there's a good chance that people regularly using those routes will pay for a faster service. And like Daryl said, it's about giving people back time. And that's really what we're exploring in the Skybus program with Daryl at the moment. In other words, we really need to find the right problems to solve in each use case. And I'm a big believer that in most of these general use cases, you can find routes that are problematic and that could benefit from aerial solutions.
So I was going to add to that. Sorry, the interesting use cases that we're looking at in the Skybus. I think the most interesting one is mind the gap, or it's what I'm calling mind the gap, because what we're looking for is the gaps within the transportation network, so the public transportation network. Where is it difficult or time consuming to get from one part of the city to the other?
And TfL has some wonderful statistics out there and tools that you're able to use to identify where those areas are. And they can help identify the potential flows between that. And then we're working with CPC and others to try and understand who's actually doing those types of journey. The other use cases, obviously things like ferry replacement services, or you can take a look at feeding cities type services where you're seeing large flows of traffic between different areas. So a great example of that is Leeds and Bradford. When we've looked at some of the data there's just huge traffic flows back and forth, but there are significant delays on the ground during those peak times. So it really does come down to that specific use case.
Yeah, and as Future Flight, we were looking at cleaner modes of travel as well, which would be in the environmental factor would be quite a benefit as well. I know the Uber Elevate report opened up by highlighting the stress levels that are increased with your length of commute time. So looking at a societal improvements as well to your everyday life, we were to factor these things in as well. I'm sure we can see the benefits. So do you think the lower economic benefits for urban and rural advancing mobility reflected in the study are short-term? And do you believe there may be greater economic benefits in the long term? Craig mentioned that drones seem to be the vanguard for introducing these new aviation technologies. Where does this fit in the time frame of developing future flight technologies?
Right. So I think the rule case that was set out, it quite rightly points out that there's a lot less utility for that route. I think when we start doing some of the analysis of it and testing it based on production volumes, and you start to see costs coming down, then we start to see some of those changes. I think the interesting bit was maybe in the choice of the number of seats and the load factors. So there's lots of room to play there, because I would imagine that future operators of these services are going to be very aggressive in their pricing models and their marketing campaigns to try and make sure that they're getting the highest utilization possible out of those aircraft. And it's a known fact that an aircraft is not making money unless it's in the air. So you really need to try and look at that. I also think that the first adopters of these services, in terms of the operators, they'll be going for those very thick routes where you're going to see a huge amount of demand for it. So again, they'll have much higher utilization of those aircraft in terms of the load factors and the number of times that they're flying in one day. So I'm actually predicting that we'll quite quickly move towards what I'm calling an electric low-cost carrier model. In that, as we get more and more carriers into the system, the price pressure will just go down, and then of course the price goes down, and then people start using it more, so that we move to commoditization of the service quite quickly. So I don't know if I've quite danced around your question or not. That's kind of my view on it. I think there's lots of assumptions in the PwC. It'll be interesting to see what comes out of it. Obviously, in the last couple of weeks with Archer Aviation and their SPAC and Joby Aviation, and there's some very interesting numbers coming out of them. It'll be very interesting to go back and maybe revisit some of the baseline assumptions and see if we come up with the same numbers.
Thanks. And so do you think there are other particular factors that would paint a very drastic picture in terms of the assumptions that we've made?
Pass to Firkin while I think about it.
Well, Craig.
Yeah. Let me jump in there, given it's, I guess, our numbers here. Yeah, so as I touched on in the presentation, so we have made some assumptions about, for example, Darren touched on this as well, near-time global production volume, and it's not very large. It's 500 units per year globally. Once that starts to kick on, the economies of scale will have a major impact on the attractiveness of these states. We know that, so that's definitely the case. And again, in terms of the modeling, now in this report, we picked a very niche case for the last mile drone delivery, but we didn't pick a very niche case for the AAM scenarios. Now, if we'd done that, which Daryl and Firkin are referring to, we could have had a different picture. We elected not to do that. But what I would say to, I guess, Firkin and Daryl in particular is Yeah, if we can find these niche cases, they might look great, they're very attractive. But what about things like the societal acceptance? I mean, yes, you might be able to find a gap in the transport logistics in London, where urban air mobility vehicle will be fantastic. What are the practicalities of getting the infrastructure to land and take off? And will society accept the volume, the disruption, how are you factoring that into your view of how attractive this is going forward, even in the niche cases?
Right. So I got part of that. Your audio was dropping out, but I take it some of the societal questions is a big one. And absolutely, I agree. I think social acceptance is the most important thing that we have to get as an industry if this industry is going to take off. Did you have a chance to hear Jobin speaking the other day? He put a post on his website and they actually had their aircraft taking off in the background. If you haven't seen it, I would strongly recommend that everybody go and take a look at that because it's absolutely gobsmacking. I knew they were going to be quiet, but I can't believe how quiet they are. Not all of them will be. I think Skybus is going to be a larger vehicle, larger noise footprint, but then that really comes down to the infrastructure equation in terms of trying to make sure that you're picking the right location for that. And in all of my presentations, I talk about UAM or advanced air mobility has to complement and not compete with public transport. So we need to work with local authorities to make sure that we pick the right places. So you get the right combination of lower noise and then eventually you get the lower seat costs for users. That's where you increase social utility, and that's really what's going to tip it over. Because right now in London, there's a 5 decibel bias against helicopter operations because there's just no social utility associated with it. The average person just can't afford it. So it's actually louder than what I'm hearing it. But electric aviation will flip that economic model upside down. And then all of a sudden more people will be able to access it. And the really perverse thing about it potentially is that advanced air mobility may actually lead to higher social acceptance of helicopter noise.
Okay, very, very interesting. I think also the societal benefits, once we start factoring that in, I can just think of the time saving as well as how that impacts your own health and well-being. Being able to give yourself time back in long commutes, and we all know what it's like, would really paint a positive picture for us. So Furquan, we see that traditional aerospace and large non-aerospace organizations, should I say, are diversifying into this area along with startups. So we're seeing GKN, Airbus, Hyundai, joining the likes of Lilium and Vertical Aerospace, etc. What attracted GKN to this market, and what do you believe is attracting these similar organizations to this AAM market?
Yeah, the market has rapidly gained a significant amount of attention in the past few years. Uber have done a great job really in gathering a lot of that traction. And we're always on the lookout for new opportunities when we believe the time is right. The belief that advanced air mobility can truly change how we travel and make a huge difference in our lives in the longer term. Also comes with the belief that there will be several commercial opportunities for both small and large organizations. Products and technologies that we've developed previously, that we are developing now, and that are on our development roadmaps, that we think have a nice exploration path with advanced air mobility. And there are really a number of synergies around some of the work we're doing now as aerospace manufacturers with some of the work we'll be doing in this new and emerging market.
Okay, and so what role do you think these large organizations play in advancing air mobility? How can it support and accelerate advanced air mobility alongside startups?
Yeah, I think startups are generally seen as faster and more focused in their R&D. Mm-hmm. Has to consider the opportunity cost of investing in more disruptive trends like advanced air mobility that may not be a core part of the current business, impacts the products and services they provide to their customers today. Eventually, I think there will be both collaboration and competition between small and large companies. Some of these startups are already our customers or will be our customers in the future, and some of them will be our competitors.
We've definitely seen that with the Future Flight Challenge Phase 2 competition, where we have quite a mix of consortia, a lot of them mixing with big aerospace and small startups as well, to form very strong consortia. So we will continue to encourage that in the Phase 3 of the challenge. What do you believe are some of the main barriers for implementing AAM? I'll go to Berkwan first. What are some of the barriers, do you think?
Yeah, I think there's a kind of general acceptance of some of the, or I guess the general challenges around technology such as autonomy and trying to remove the pilot from the vehicle, including both type certification of the vehicle as well as operational approval, noise and public acceptance that most people agree on. I personally see is looking beyond the hype curve and maintaining resilience if things go well over the next couple of years. Most organizations that I think are serious about advanced air mobility know it's not about making a quick buck. It's a much longer term, it's a much longer term play. And this is really what I think the priority for the future flight community should be, both industrial and government. Keeping faith in the transport system concepts and the benefits that actually started the market in the first place. We're going to need a sustained level of trust, a sustained level of investment and innovation, regardless of whether things go according to plan or not, if we want to get to maturity.
That's really important. That was my next question. What would be on the top of your wish list for government and industry to be really pushing right now? And I like that term, making sure that we maintain beyond the hype curve. That's really important. Daryl, Craig, can you share your thoughts on this? What should be top of the priority list for our sector in addressing these barriers?
Go ahead, Craig.
Yeah, I think for me, obviously, there are technical barriers, and those are very important, and they are wide-ranging. But for me, it's the sort of grittier, more practical things. So we mentioned societal acceptance before. There's also the urban planning required to get the takeoff and landing locations. That's a biggie. And think about the existing process that needs to be, shall we say, gone through for urban planning to be approved. That's kind of a big deal. And then we have all the other various actors, and so. How do we address when these particular air vehicles go a little bit wrong or they go a bit rogue? What's the counter AAM solution, and how does that impact the trust that society has in this new form of transport? So for me, I think I tend to see the more societal things, the more infrastructure things as being bigger challenges, and of course you have to fix all the good aircraft and UTM, ATM elements as well. Critical, of course, but I think we need to see this from a holistic, wide perspective and make sure we're actually addressing all of the things that need to be in place to actually deliver this as a business as usual model. But, just to echo what was said before, I think if we can find some great niche use cases, we can find some quiet AAMs, then that could very much pioneer or plot a path to getting a more ubiquitous use of this technology.
Okay. So conscious of time, Daryl, I'll ask you, what are your recommendations to build on this study?
Right. So yeah, I think it'd be great to go back and start applying some of the numbers that are coming out of the various SPACs that are going on in the US, especially when we're talking about the amount of revenue that they would generate per vehicle and their operating costs. In particular, a good analysis of some of their utilization numbers that they put in there, which I think might be a bit high, a bit aggressive, but that's fine. It all depends on how you define things. It's how long is a piece of string. I think not necessarily leading out of the study that PwC have done, but stuff that we need to do as industry and people who can influence it is actually working on the social acceptance angle of it. So dealing more with societies, but also a lot of work with local authorities to help them understand what the benefits are. So Craig is quite rightly pointed out that we haven't got the appropriate planning legislation in place to allow for an assessment of a vertiport application. You could say you could use helicopter. Yeah, you could probably in the first days, but it's probably more appropriate that we have a different set of criteria, because we're looking about commercial volumes of traffic in terms of people being moved on this. So it's a different way of looking at it from just an ordinary heliport. So those are part of the areas that I would like to see come out of it. The other thing is actually looking at more of getting some real demand modeling work going. And I've been doing a bit of demand modeling. I've done an assessment of 15 potential routes in the UK with some unique data sets. And we're coming up with some really interesting numbers that across those 15 routes, we could save 625 years worth of travel time. So people stuck in traffic on road and rail, we could save 80,000 tons of carbon dioxide emissions, assuming that you have electric aviation. But it's actually the route analysis and the actual frequencies that you get out of that demand model that would allow investors to make business decisions on what's going forward and how they actually do that. We've had some great studies by the Big Five outlining the value of the electric aviation system, but what we actually need is some real bottom-up demand modeling, which is something that I'm moving into that space, and you'll be hearing more about that in the coming weeks and months. So yeah, that's where I think we should do. It's been a great study, a great start. It's given us some information that we actually used in this micro study, so this 80,000 tons and actually the economic reclaim. So we calculated on those 15 routes, you could get 198 million back into the economies, and it addressed things like leveling up and Northern Powerhouse significantly. So again, it's getting concrete data to allow people to make those investment decisions into infrastructure and into vehicles and systems and processes. So that's where I'd like to see the next piece of work.
Okay, fantastic. Now, conscious of time. Sorry, go ahead. Go ahead, Ferdinand.
Yeah, just to quickly add to that, I think one major factor we've just started discussing in the Skybus project, and something I'd like to see really in future studies, is how passenger movement, residential locations, and preferences, commute times, and travel patterns actually will change when some of these services are expected to be fully mature.
Yeah.
I know people are planning for initial services 2023, 2024. I think there's kind of a general understanding that full maturity will be closer to the 2030 timelines, maybe 2028, maybe beyond. And whilst this requires further forecasting, which introduces more uncertainty, I think it starts considering a more accurate representation of the world in 10 years or so.
Mm-hmm. Okay, that's good. That's very interesting. I'm conscious of the time, so I'll take one question from the audience, and we'll provide answers to the rest offline. So what are some of the marketing requirements initially for cargo and then for passenger drones? What do you expect the market to be B2B on, or consumers? Whoever can answer in like 1 minute. Any thoughts?
I can jump on the cargo case. Yeah. So we're initially looking at B2B rather than consumer deliveries. Of course, in our case, we're sort of the middle mile, so that's natural. Consumers, however, as we saw with the pandemic, are more and more turning to not sort of the regular employment, but more into creating their own SMEs and selling online and so on. So from that point of view, yes, we see an uptake there as well in the future. But these are two very different audiences, and marketing is naturally quite different.
Mm-hmm. Okay, understood. Okay, so I'll thank my panelists now for their time and for their contributions. Like I've said, we'll take any unanswered questions offline. So if we move on to the next slide. So I hope you found this session informative and useful, and we would be looking to continue building on this information and to share with the Future Flight community. Please join us next month for our next session. Is going to be Women in Future Flight, as we're celebrating International Women's Day next month in March. Next slide. And if you'd like any more information about the Future Flight Challenge and would like to connect with the network and find out about collaborators, then this slide shows the contact details. So thank you very much for your time, and thank you for the panelists. Thank you to the audience for joining, and I look forward to seeing you next month for our next session. Thank you.